Today we're going to talk about literal equations. Now I know it's been a little while since you've been in algebra, but I'm going to guess that you have an idea what an equation is. You know that it's got an equal sign and the left side and the right side then are the same. But now what? How do we solve a literal equation that contains, honestly, more letters than probably numbers? Well, the answer is the same way you would solve an equation that does contain numbers, but this still, it can be a little complicated. What I'd like you to do is talk with your neighbor about how you might solve this literal equation for f. Go ahead. I want you to talk to your neighbor. What do they think? What do you think about solving this equation for f? Now, during this time, students are being honest. You may hear some students sharing about doing some adding or subtracting of some type of expression. You might hear students saying that they aren't really sure. And maybe somebody's talking about that these are fractions, and particularly that f is in the denominator, which is a problem. And well, let's come back together. Now, instead of having you share out about what you talked about, we're actually going to solve this problem at the end of the lesson. And the idea is that some skills that you might develop through this lesson can help you to be a little more sure about how to solve. So let's look at some literal equations that are on your sheet 0.1, and honestly, some that are a little bit more doable. Now, instead of necessarily talking to your neighbor, I'd like you to look at these three equations at the top, and now you do some algebra to see if you can solve each of those equations for the indicated variable. Okay, now again, at this time, students, and I would expect that you are actually pausing the video so you can actually solve as best you can any of these three equations. In just a moment, we'll come back together and we will find out what the class thinks. During this video, I will tell you what I think. All right, let's begin with this first equation, which says that ax plus by equals c. Now, in order to solve this equation for y, and honestly any equation you're trying to solve, what you're really trying to do is take all the expressions and variables that are around that letter and move them to the other side. So we can definitely see that there's an ax and there's a b that are around this variable, and we need to move them to the other side. Now, the way that algebra works when you're solving an equation is that you actually do the order of operations backwards. That means that anything that you can add or subtract is actually done first. You see, this ax is actually a term that is being added in its current state. So that means we're going to subtract it because we want to, of course, do opposite or inverse operations. And yes, you can subtract that entire expression to the other side because, well, that entire expression was originally, it was being added to both sides. Now, that leaves me with by equals c minus ax. Now, there's still a b that is basically with our indicated variable, and it's being multiplied. Since it's being multiplied, what I want to do is I want to do the opposite of multiplying, and that answer is I would divide. Now, that's easy to do, but do you understand that you must divide the entire equation by b? You must divide the entire side by b. So as you can see, I created a large division or fraction bar, and that leaves me with c minus ax over b. Now, that answer is fine, although the rules of fractions say that I can take my denominator, which is b, and I can actually distribute that over the entire numerator, which leaves me with an equal expression, although it looks a little different because, again, we distributed the denominator. Okay, but now we're solved for we're solved for y, because obviously the letter y is all by itself. How about this equation? We want to solve this for b. Now, there's different ways that you can go about this. We're still trying to get the letter b by itself. That means we got to do something with a, and we got to do something with the 1/3. And I will hear students say that they might choose to distribute the 1/3. It's not wrong, but what that actually does is that actually puts a extra fraction with the letter b. We want the letter b to be by itself, so instead of bringing that 1/3 over with the letter b, why don't we do the opposite of 1/3, which would be 3, or 3 over 1. You see, what I'm actually doing here is I'm multiplying both sides by the reciprocal. And again, that reciprocal would be 3 over 1, or just 3. And that leaves you with 3a equals now just a plus b. As you can see, I no longer have the fraction, and it's pretty easy to solve this for b, that is, to move this a by subtracting it. Now, it's a different a, just because it's a different variable than the uppercase a. So that means that 3a minus lowercase a are not able to be combined. We just leave them as two separate expressions. Now, in this equation, we should see that we actually have two variables, or I should say a repeated occurrence of this same variable h. Now, that creates a dilemma, and the truth is it requires us to use some algebra that maybe we have to dust off a little bit, but I'm confident that you have studied. Whenever you have a variable that is repeated, and you're going to hear this many times this year, we always will factor that variable in order to be on our way to solving. So yes, it's very common to factor out a h, or a repeated variable, and what this means is that we are left with, whatever was not factored out, that in this case 2a plus 3b. Why did I factor out those h's? Well, I hope you can see that now I just have a single h. And if I'm trying to solve my equation for h, it's implied that I want it to be only one h. Now, this 2a plus 3b, this is being multiplied by our h. Well, when something's being multiplied, we can do the inverse. The inverse operation in this case would be to divide. Can I divide by both of these at the same time? Well, I sure can. In fact, you have to divide by the entire expression, and the parentheses are making that a little bit more evident. So I end up with this answer that looks like g over 2a plus 3b. And that, of course, is equal to a single h. Well, if that doesn't get you, kind of wake you up with solving equations, I'm not sure what might. But let's sort of summarize the best we can what has happened in each of these equations. Probably the big idea is the familiar phrase inverse operations. Inverse operations are when we are really the only way for us to undo an equation. And you always do the inverse operation to both sides. Of course, that is how we can cancel the one side of the equation when we're solving. Now, did you notice that for each one of these equations, I did always work with the order of operations. So can I abbreviate that? Order of operations. I did the order of operations backwards. And you could also argue that I worked from the the outside of my equation to the inside. It's hard to summarize that in just a few words, but it is true that when you're solving an equation, those are your going to be your common strategies. Now, that is until we get into some special strategies, like the last one that I did, where I did some factoring. And if you remember, the reason I did some factoring was because we had a repeated variable. That is, the letter H showed up a couple times. Now, do you remember that equation I had up at the beginning of the period? We're still not going to go over that, but the reason I share is that this too is a special equation because, well, because of the fractions. And what we're going to do is we're going to leave a little bit of space for another statement about how you deal with a problem that has those types of fractions. In other words, there are going to be some special cases. Shall we continue solving some literal equations? Here we have the equation for the volume of a cone. Now, you don't need to know that to be able to solve it, but what we do want to do is we want to see if we can get this letter R all by itself. Now, there's a lot of things that are around that R. There's a 1/3, there's a pi, there's a square, and then there's an H. What we want to do is we want to do the inverse of those, and we kind of want to work from the outside to the inside. What I want you to notice or be able to agree is that basically we have three items that are on the outside. We have a 1/3, we have a pi, and we have an H. Now, we can actually, if you will, remove or do the inverse of each of those all at the same time. It makes for a little less work, maybe makes things a little cleaner. So how do I get rid of that 1/3? Do you remember? Yes, we use a reciprocal. So what's really happening is I'm going to multiply by 3. So if I multiply both sides by 3, it'll cancel with the 1/3. How do I get rid of the pi? Well, I divide it. So I can divide both sides by pi. Well, it's the same thing with this H. And yes, I can do both of those in the same step. That is, I can make them into just one denominator. So we're going to multiply by reciprocal, and we're also going to divide, and that leaves us with something that would look like 3v over pi h. Now, you'll notice I didn't do anything with the square, that is until now, because that square kind of works us more to the inside of the equation. But the opposite of a square, that's right, is a square root. And so we will use a square root to cancel the square, but I want to do the square root of the entire fraction I have over here, and that just means that I'm going to have an answer that looks like the square root of this entire 3v over pi h equaling r. Why would I want to solve this equation for r? Well, maybe I want to know more about the radius of a cone if I already know what its volume and height would be. And if that be the case, I could just kind of plug into my, well, to sort of my new formula. Here's a literal equation. You might recognize it as the perimeter of a rectangle. This is a classic equation that contains, obviously, addition, but it also contains multiplication. And so what we want to do is we want to make sure that we follow the correct order of operations. And you remember what we said about the order of operations? You actually do those, well, you do them backwards. What that simply means is that we're actually going to take care of the addition subtraction first, and the only term that is being added or subtracted is this 2w. How do you take care of it? You do the opposite of adding, you subtract. Notice that I'm subtracting the entire quantity, and that will leave me with something that looks like p minus 2w. Now, I'm still left with a regular 2 that's being multiplied, but we can just take care of that by doing the opposite of multiplying, which is dividing. So we'll divide both sides by 2. How do you write this answer? Well, you have to be comfortable realizing that you can write it as the entire p minus 2w divided by 2. But you might recall that I said that it is legal to, in a sense, distribute the denominator. And if I distribute that denominator on the p, I still have the denominator of 2, namely p over 2. But when I distribute it onto the 2w, I get a nice little cancellation. And that, of course, just leaves me with a w. So both answers are fine. It's more of understanding that you can do this if you want.